You're listening to Inside iOS Dev, show about real-world iOS development. Today with you, your host, Alex Bush. And today I have two very special guests. Both of them already been on this podcast. So I have Sandeep Agarwal and I have Jeff Gilbert. Sandeep is my coworker. I've been working with him for probably half a year now, and Jeff is a very prominent person in the iOS community, the author of VIPER architecture. But anyway, I'll let you guys briefly introduce yourself. Sandeep, let's start with you.
Yeah, okay. So first of all, thanks for having me again, Alex. So, hey guys, I'm Sandeep Agarwal and I'm working on iOS apps development for past 7 years. So yeah, so I'm now keenly more interested in doing the architectural work I got it more inspired from Alex. Yeah, that's it. Head over
Great.
to you, Jeff.
Mm-hmm.
Thanks. I'm Jeff Gilbert. Thanks for having me on, Alex. It's great to meet y'all and talk to everybody. I'm a principal engineer at Literati down in Austin, Texas, where we do a number of book club memberships. And I work on the iOS app for the Luminary book club. I've been doing iOS work since about 2010 and working on other Apple platforms back in the 80s with a few excursions into the embedded world every once in a while. So it's been a lot of fun.
Yeah, I think now I just thought about it. You probably have like twice the, at least in the number of years, twice the experience of both, or rather mine and Sandeep's combined or something.
Well, as you know, the great thing about this industry is there's never too much to learn. There's always something new you can do.
That is very true. That is very true. So the reason for kind of this quote unquote get together, if you will, recently Sandeep and I were working on a feature that involved sort of a more, not holistic, but maybe holistic changes in our application that involved logging in and logging out and sort of going through basically all the layers, fundamental layers of the app of like signing in, authenticating, getting all the push notification tokens and all that stuff. And that gotten us into a very much archaeological adventure. I felt like Indiana Jones sometimes. Of like old legacy stuff that wasn't touched for years probably. The code base that we have is about 6 years old, and portion of it, and that fundamental portion of starting the application and logging in, logging out, was implemented as VIPER architecture. The rest of the app isn't VIPER or Viperized. But as we would go through it, I would notice that from my perspective, it's actually not a fully finished, if you will, implementation of VIPER, the way I understand it. But then Sandeep kind of started to research on VIPER himself, and he found a different explanation and understanding. And we basically kind of thought, well, neither of those is wrong, because I kind of have my resources working at, say, Wayfair, where VIPER was everywhere through and through. And he has his articles and resources, which, yes, outline it differently. So we thought, well, why don't we just talk to Jeff, who invented this thing? And because I'm sure your understanding, Jeff, is way different from ours.
Yeah, and it's certainly evolved over time. As you say, I started working on this around 2012 or 2013. And so I've certainly come to understand things more and more and sort of the overall and how it can help me achieve my larger goals of crafting software.
Yeah, and I wonder where we should start. Probably, Jeff, maybe like super briefly give us the high level idea of, what VIPER is and why, and then maybe Sandeep and I can show you sort of what we found out there on the web. explain
Certainly.
it.
Yeah. So it all started because I was interested in test-driven development, TDD, and as I was, getting the hang of iOS finally after a year or two of doing it, I was able to turn my attention to larger problems such as architecture and things like TDD. And so, to do TDD, you sort of have to be able to create a testable architecture so you can write the tests first. And so it was sort of my exploration of how do you architect a testable iOS app, and VIPER is sort of the result of that. And so first and foremost, VIPER is very much optimized for doing test-driven development. So if you aren't interested in doing TDD, a lot of it may seem unnecessary, but that's sort of the foundation of it. And sort of the architecture came out of a lot of the clean architecture ideas of Uncle Bob Martin. And so basically it's sort of a use case centered architecture where an app is just a collection of use cases. Like, if it's say if you're doing a banking app, you may have use cases like deposit money, transfer funds between accounts, withdraw money, etc. And so those form the core of your app. That's what the app does. That's what it's for. And then the UI basically acts as a plugin. The point of the UI is to present data to the user, the result of the use case, and to collect data from the user so that they can execute the use case. And then you also sort of have the notion of a data stored, generically speaking, a database, but these days it tends to be, a backend that you talk to either via REST services or GraphQL or what have you. And so basically, the use case will get data from the user via the UI so it can execute its work, and often it will talk to items in the database, like it'll probably make calls to your backend server to get data, manipulate it based on whatever the business logic is for that particular use case, and then maybe store the results back out and then present the data to the user. And so you sort of have that separation between sort of the core use case or sort of the business logic and then the UI. And that's basically the primary components.
Right. Yeah. And that's actually so interesting. Now you're describing it. That that is not what Sandeep and I talked about and found out there as some parts of this sort of architecture, especially use cases part. It's not what it ends up being for some reason out there. So, okay, maybe Sandeep, how do you think you could sort of outline what your research uncovered and how
Yeah, sure.
you understood it?
Yeah, sure. So the brief overview which Jeff gave us regarding the VIPER architecture, like that was already clear in our mind, like what VIPER is and what the each letter of the acronym means actually. What we were really confused was about the interaction of these components and how one component can know each other. Like, let me share you with one screen. See, can you see the screen, guys?
Yep.
Okay, so here is the one when I actually learned the VIPER architecture. This is how I learned it. Like, what should be, which element should interact with which element. Like, presenter should only know about the router part, and but vice versa is not possible. And interactor should interactor and presenter should both know each other. So that was, I think, the main confusion. Right, Alex?
Yeah, there's okay, I'll kind of show my diagram and kind of my explanation and my perspective on it right after you. Don't
Yeah.
worry about it. We can then talk about the differences between them. Essentially, I think what it boiled down to, though, like those articles that you found and this particular diagram is presenter being the center point of everything, essentially, right? It
Right.
is, if you will, with an asterisk, the business logic of each VIPER stack or like VIPER collection of VIPER objects, just through the sheer fact of it being this, well, again, quote unquote, central point that coordinates stuff. Yes, technically, interactor is the kind of business logic that coordinates things for core data and or networking, but then presenter tells it to do it and when to do it, right? And then it tells the router to route somewhere or not, or tells the view to display something based on what interactor produced. Again, according to this, right? And this was pretty similar to what we have in our code base. But notice one interesting thing as well. This does not have a concept of a use case kind of at all, I guess, right? And Jeff, I don't know, kind of originally, have you thought of use cases as being like actual objects and types and classes, or more of a collection of objects like interactor plus entities being a use case?
Yeah. So, and so as we talk, I basically, so as you see on the diagram, sort of VIPER is sort of a backronym for view, interactor, presenter, entity, and router. I basically don't use those words anymore. And so really, so like the view, interaction, presenter, I refer to them sort of more as the responsibility of the designer that they belong to. So the interactor is the use case and what is sort of the business logic. And today I refer to that as the business design. Of course, since most apps these days are based on network services, most of the actual real business logic does happen on the server. So, for modern mobile apps, the use case tends to be pretty small, pretty simple and straightforward, since it's sort of pushing a lot of that work off to the server to do it. But so in terms of the use cases, the interactors or the business design actually are the use cases. And they certainly do pull entities from its quote database. And so entities are the same thing as models. So if you were to do, say if you're working on a banking app and one use case is you want to transfer funds between two accounts. Sort of the use cases, sort of the data that you need is you need the source and destination accounts and the amount to transfer. And all that comes from the UI. And we can talk about that in a minute. But then the use case, the business rules is if you have a source and destination account, let's say you want to transfer $500 from savings into checking, you first have to look to see if you have at least $500 available in your savings account. And if so, then you subtract 500 from savings, add 500 to checking, and then sort of commit those new balances to the two accounts. And so that really is sort of that is the sort of business, and it is very high level and abstract in the sense that those banking rules are unlikely to change. That's probably been the ways how banking has worked forever. And so then the UI is basically it sort of acts as a plugin, as in the interface to the UI portion of the UI architecture is dependent on and driven by the needs of the use case or the business design, or in this case, the interactor. And so together, the presenter, the view, and the router all make up the UI that act as sort of a plugin into a particular use case. And so the presenter is really, these days, I just refer to it as the interaction design. And then the view I refer to as the visual design. And then the router I just call the navigator. And we can talk about navigation because that forms one part. The router forms one part of navigation. There's several parts that all work together. But so as you say, the interaction. So I tend to think of the interaction design as the quote business logic for the UI. So it's regards like how the content is formatted for display, like formatting dates and currencies and things like that. And then just feeding those. So typically the presenter or the interaction design will receive models from the use case, and then it will format those into, these days I call them presentations, which are simple structs, but it contains formatted data. So instead of like a decimal value for a currency, is going to be a string that's already been formatted into local currency, etc. And so the presenter takes the models, creates presentations, and it just hands those presentations off into the visual design or the view for display on screen. And so at that point, then the views are really simple. It's just taking values from the presentation that's handed and just smashing it directly into whatever widgets like labels and buttons, etc.
Right. Essentially, at that point, they're primitives like
Right.
strings and ints and whatever else, right?
Right. And so the presenter does tend to be one of the more complex objects because it is sort of doing both. It's sort of serving two functions. It is sort of responsible for communicating, as you say, with the interactor, like collecting data and presenting it to the interactor or the business design so it can do its use case work. And then it's also responsible for communicating with the view or the visual design. So it can say, here's some data I want you to display, and then gathering data from the visual design or the view as the user, taps on the screen. It sort of sends data back into the presenter so it can collect it and hand it off to the use case or the business design at the appropriate time.
Mm-hmm. So would be then if in cases when you need to navigate or route somewhere, would be the presenter would be the one telling the router to do that?
Right. Yeah. So when you're navigating typically between screens, there are sort of three key questions you need to answer. You have to know when to navigate, where to navigate, and how to navigate there. And so the router, which I call the navigator these days, is typically responsible for knowing how to navigate somewhere. So if you say, I want to go to the transfer fund screen, it knows how to use the factory to create the appropriate view controller and maybe push it onto the navigation stack or present it modally or whatever is appropriate. The other two questions of when and where do you navigate, most times that actually can be handled by the presenter or the interaction design. So if the user, say if you're on a main menu screen and you tap a button to say I want to transfer funds, you know when to navigate because they tap the button, and you know where to navigate. Since they tap the transfer funds button, you want to navigate to the transfer funds screen. So at that point, the presenter can tell the router or the navigator, go to the transfer funds screen. And at that point, the router takes over. There are cases sometimes where the interaction design or the presenter actually can't answer both when and where. Sometimes it can know when to navigate, but it may not always know where. And that's when I've seen that so far is like sort of when you have these sort of multi-screen flows, like maybe you have a little modal and you have a few screens you can go through, and depending on what you do on screen one determines where you go on screen two. So in that case, the interaction design knows when to navigate, like, oh, here's some content, but I don't have enough knowledge to know where. And so then I introduce what I call a flow object, which sort of has it spans across the lifetime of multiple screens. And so it collects data from all these different presenters. And whenever it gets new data, it can take what it already has on hand and say, oh, okay, here's the next step you need to go to. So the flow knows where to navigate. And so together the flow and the presenters can figure out when and where to navigate. And then again, in that case, the flow would tell the router or the navigator, here's where I want you to go. So take me there.
Interesting. So the flow is kind of like even higher level coordinator object, if you will, from another architecture, right?
Yeah,
coordinators.
Yeah, because basically presenters tend to have the lifetime of a single screen, and flows have the lifetime of multiple screens.
Right.
But again, they're pretty rare. I don't use them that often. Most of the time, the presenter on its own can determine when and where to navigate, and then it just tells the navigator where to go.
Mm-hmm. Interesting. This is so interesting. Okay, let me show you guys, and I'll kind of show both. Let me show you the diagram of what I have of my understanding from, like, let's say Wayfair and other companies of the VIPER architecture, and then sort of we can contrast it to this, right? What we just looked at. So this is how I've seen it implemented, which is essentially router plays like a dual role for the whole VIPER stack, if you will, of routing and being a factory that assembles it, if you will. And essentially what it assembles, kind of two pieces, really. Well, okay, sorry. It assembles three pieces: interactor, presenter, and the view, and it owns interactor and the view. And then interactor is that main business logic thing, where kind of like here it's in this presenter is in the center. It flipped a little bit, where interactor is more in the center, and it tells as data is fetched or I don't know, some computation happens, right, that needs to happen for business logic purposes using entities, if any, or service objects, whatever you would have for that, then it will either tell the router to route somewhere to a new screen, or it will tell presenter to, hey, display these models. And what you, Jeff, were explaining, then it maps one-to-one. Like presenter gets the model objects, maps them into view models, and essentially they're passed to the view. And presenter basically says, hey, hey view, here's a bunch of view models / structs, render them, right? But presenter wouldn't be the one routing, or telling the router to route or navigate, right? It would be the interactor. That's kind of the crux of the difference, I think, between those two.
Okay. Yeah. Well, I guess going back to the core principles, are you able to sort of test the different portions? Are you able to test the interactor in isolation and the presenter, et cetera? And if you can, and that's working out for you, then that looks like a really good solution.
Yeah, right. And that's exactly, you nailed it. That's the whole point of all of this, because all of those things in either one of those approaches, in between, though, there are interfaces, right? Protocols. Right. So everything that's connected to each other, it's connected through a protocol, therefore, and injected, right? Therefore, you can mock it, stab it out and mock it and unit test. Or even change at runtime, right? In certain whatever circumstances where you want to flip, change at runtime what it's going to be actually, right? Whatever object is hiding behind, it doesn't matter what object is hiding behind that interface, right? As long as it implements it, you can rely on it.
Exactly.
So, solid principles are fantastic in this case, right?
Yeah. Yeah, and so really, I guess one of the other core principles that sort of drive our, VIPER is, the single responsibility principle, in that only one, quote, role or person should ask you to make changes to a class. So the way I see single responsibility is it's responsible to a single, designer, and sort of harkening back to the great Steve Jobs quote, design isn't how it looks, design is how it works. So really anybody that's involved in defining how an app works, I consider a designer. So certainly the obvious ones that everybody thinks of when you hear designer is you have interaction and visual design, but I also consider business design one of those design roles, and that tends to be what you think of as the product people, sort of like bankers would be like the business designers of a banking app because they understand how banking works and what a banking app needs to do. And so really the interactor is responsible to the requirements of the business designer. The presenter is responsible to the requirements of the interaction designer, and the view is responsible to the requirements of the visual designer. And so that's why you sort of get that good isolation, and all three of those are testable in isolation because you aren't, the presenter isn't mixing up responsibilities of, say, business and interaction design.
Yeah. Interesting. I think another sort of something that we encountered, and Sandeep, maybe you can weigh in on that if you can, with sort of VIPER, how do I put it? What's missing, if you will, for the lack of better description, is kind of assembly of VIPER, collection of VIPER objects, right? Assembly and or initialization, aka factory, right? What we end up doing in several places in our refactoring efforts is to kind of actually, literally extract factories.
I think what you meant is module, to actually create a VIPER stack.
Yes, we created those factory module objects for, again, couldn't come up with a better name, but they would be collecting or initializing anything that interactor and or presenter need in terms of like service, this core data service or networking service or whatever else, and then creating presenter, interactor, and the view and I think the router as well, right, Sandeep?
Yeah.
Yeah, and do you, what's from your experience, Jeff? Like, I think you mentioned factories, right, a few times. Is this something that kind of often start to come up or evolve? Because, for example, at Wayfair, this whole factory duties were shoved into router, and router kind of became very large and had dual purpose, unfortunately.
Yeah, so in mine, so like the router or the navigator, it is responsible for knowing how to navigate somewhere. So when you tell a router, take me to the transfer funds screen, it's so the way I have it set up is that the router or the navigator has access to a factory, and so it can ask the factory, get me the transfer funds view controller, and it'll get back from the factory, and let's say it'll push it on the current navigation stack that it sort of owns. And so in this case, like the navigator is sort of the one that's responsible for controlling the contents of, generically speaking, a container view. So like navigation controllers, if you pop up a modal, it would be in charge of that modal view. And certainly like may have an application wide one that is responsible for the root view of the root view control of the window. And so I tend to have multiple navigators in the app, and I have a separate factory associated with each navigator or router. And again, those tend to be tied around lifetimes of containing view controller. So if you're going to, say if you want to need to pop up a modal of maybe 3 or 4 screens in it for whatever reason, that will have its own navigator that's responsible for that modal, and probably the navigation controller inside of it controlling all the views. And then it is responsible for creating the view controllers, the 3 or 4 view controllers that you would likely see inside that modal. And so certainly the factory is guaranteed to have the lifetime of that, say, modal. And so it can have, so it can hold on to all your dependencies that you need. And you may only have dependencies that only make sense to exist during the lifetime of that window that aren't available for the lifetime of the app. But as long as, but so that factory can hold on to those. And then when the modal disappears, the factory goes with it. And anything that it was holding on to also goes along with it, and gets released from memory.
Mm-hmm, mm-hmm. So the factory would be then that assembly place that creates or gets dependencies, and then creates the router, interactor, and the rest of the stuff, right?
Correct. Yeah. So a lot of times, like since factories and they're typically associated with the router, so they're told the router that they're working with. But yeah, so it will certainly the factory has this possibility of sort of piecing together the sort of interactor and presenter in view that you need to work with, and then also injecting any dependencies needed by them.
Mm-hmm.
And so the factory would typically be maybe if factory B depends on a few items with a longer lifetime, factory A may provide those in the factory B. So say here's your network service that you're going to use or whatever.
Interesting. Okay, so how would those imagine you have a screen. Maybe I could draw it actually. Now I think about it. Let me see. What if you have something like this? Bear with me. What if you have, I don't know, some, as you were saying, like a container VIPER stack, right? Roughly speaking, a big complex screen. And let's say it consists of like 3 other screens inside of it, right, that are displayed at the same time. That are portions, I don't know, it's a complex e-commerce application or something like that, right? And you have, I don't know, product details or something. And then you have right below it price VIPER stack. Again, just imagine for some reason it's complex, right? And it warrants its own entire VIPER stack. And then there is, I don't know, reviews, right? Which is also complex. Like at least, first of all, correct me if I'm wrong, but the way I've been using the VIPER and so it be used, there are two kind of ways. Either people have something like this, where there's literally several Viper stacks and the containers routed to, and then it routes to those individual sub children Viper stacks, and just routing to them means attaching them as children through containment API as children vControllers.
Yeah.
Or these guys are a little bit like they don't have all of the pieces and they only have, let's say, view and presenter, and this guy's kind of puppeteering all of them with, say, one interactor, for example. What are you, what from your perspective, which way is sort of you used, and how advantages, disadvantages of the other way? What do you think?
Yeah, well, I think both approaches certainly have the time and place where they are the better choice. Yeah, so yeah, it's typical on the apps that I've had the pleasure of working on so far, is each screen as a whole sort of is its own stack. But I can see where you may have, as you say, child view controllers, and each one has its own sort of independent and separate use cases. So in the case of like product details and price and reviews, I can see where those really would be complete their own little Viper stack, where it is visual, interaction, and business design all tied together at once, and each one has their own use cases. And then the sort of the whole responsibility of the container is to just build up those child containers with their own little mini Viper stacks. Yeah, I can certainly see that as a really great way to approach a really complex screen where you have, and then the nice thing about also that approach is you can have 3 different teams working on those 3
Right.
Viper stacks without worrying about stepping on each other.
Exactly. And I think this is the reason why I saw this, because I used Viper only in large organizations and large teams. So it was teams of teams, right, essentially. And each one of those could have like 5 developers working on it, and have a zero laser focus on just the reviews, right? And make it perfect. But then another team or 2 work on price and product details.
Yeah, but I can also certainly see, let's say the 3 sort of child views, let's say they all sort of did represent slightly different aspects of the same use case. And so the container really could be a shared use case, or basically a shared interactor. And they, so as you say, since it is just a bunch of interfaces all plugged together, sort of the presenter down in, say, your price stack, it's just going to have some sort of price interactor object that it talks to, and it very well could be the one contained up in the container stack. And so all 3 just really, they all have their own interfaces, but they could all be pointing to the same object, which is contained up in the parent container.
I see what you mean. So in this case, this interactor here will be kind of fat, quote unquote.
Yeah.
But it will stack on top of each other 3 interfaces, like product details interface, product details interactor interface, price interactor interface, and then reviews interactor interface.
Right.
As far as these guys are concerned, those are different things, or maybe, right? At least there's different interfaces, but in reality, it's just one object implementing it. But if it becomes really fat and big, you can split it into 3 and get to this.
Right. And I'm hard pressed to think of a contrived example, but they really could genuinely share the same use case, but they just maybe treat the data different ways, or visualize it different ways. And so in that case, they really could be talking to the same skinny use case or interactor up in the parent, but they could just be sort of presenting that content 3 different ways. I mean, sort of like product details and price and reviews don't necessarily make sense in that example, but if you really wanted to be able to interact with and present the data 3 different ways, they could all share one use case that's given them all the same models, but then they could allow you to interact with them differently.
I see. Okay, that makes sense. Let me ask you about another.
I have a question though.
Yeah, go ahead.
So in the second case, what would be the router's responsibility? Will it be a common router for all of the 3? So for example, this product details could have like product sub details. So will it ask the container Viper to navigate to the product sub details, or it will have its own router?
Yeah, so it depends on what portion of the screen you're wanting to control or change the contents of. So if the entire screen, like say if you're down somewhere in the little price view and you tap a button, and if you want the entire screen to switch out to something else, then that could just be a thing, like all three little Viper stacks could share the same router. So when they say, I want to look at this screen, the entire screen changes. But but that's one theoretical app. But let's say another possibility is, let's say when you're working with the little price view, when you tap something, you only want that portion of the screen controlled by the price section to change out to something else. It could basically have its own little router that controls that portion of the screen. So really, let's say the price, you may have another little container view controller or container view there. You can change the contents of the quote price section independently of the others. And so it could have its own little router that is able to change out just the contents of that price section of the screen.
I see. It actually makes sense. I think it clicked for me too, because I haven't not thought about it this way. So let me find perhaps a pseudo example of a UI of an e-commerce app, so that we can talk about this. Okay, so here, right? Something like this, right? Product details screen. This is what we were talking about here. That's our container Viper stack, this entire thing, right? And then let's say this top portion is this product details part. Let's imagine that this one is the price one, and this one is reviews one, right? So let's say if you want to navigate from here to entirely different screen like this one, right?
Right.
Upon some selection, and it would be like either modal presentation or a navigation stack push or something else, but as major, like globally, the whole screen changes to a new screen, then that probably should be handled here on that level of the container in its router, right?
Right.
And you would have something like next big screen Viper stack get routed to from over here, right?
Exactly.
But what you, Jeff, were saying, if let's say, imagine here were tabs of sorts, right? For this price section, and you, I don't know, tap on tabs and like they completely change the contents of this AKA route. It's not just flashing, like re-rendering with a new piece of data. It's actually like showing a different screen for some reason, right?
Right.
Then here, that would be appropriate to have a router and do it here. But that router will only manipulate and not control, but manipulate routing within that little section of that tiny piece of the screen.
Right.
Rather than entire.
Exactly. Yeah. So that sort of goes back to the idea of routers being tied to a view container. And so most of the time that view container is sort of the entire screen. But if you wanted a view container to control just a sub portion of the screen, then you'd have a little view container for that middle section of the screen, and you'd have a router associated with it. And then as you tell that mini router to navigate to places, it will update the contents of that middle portion of the screen through its view container. That
makes a lot of sense. That actually, now something else clicked for me personally, because this is tied into another architecture that maybe we can talk about it with you, Jeff, if you want some other time. Uber Ribs, where it's fundamentally built on top of Viper, just with modifications. and they have similar thing of like routing. Okay, so it clicked for me.
Oh, excellent.
The whole how do I phrase it? As you work on this, and our listeners and viewers might think, well, how am I gonna make it this like, how do I figure out when to do it and when to not, right? And I think this decision making process could be helped greatly if you basically zoom in here as you work on this portion of the code over here. You're just in this price Viper stack, right? And you're focusing on only this piece. Think, and you need to route somewhere. And let's say how do I put it? You can ask yourself a question. Is it appropriate? Am I manipulating just this portion of the screen and routing within this little portion of the screen? Or am I manipulating the whole thing? And the decision, if the answer is not, then the decision shouldn't be made here, and it should be delegated up to the parent Viper stack.
Right. Exactly. And so it is possible that a presenter, your interaction design, may have reference to multiple navigators. And so certainly in the app I'm working on, I do have the notion of an app navigator that can sort of change out app level things like, login is a depend, so once you log in, the app transfers from the login flow into the user content, which is a whole separate navigator and stack and all that. But so once you're inside the user content navigator and all of its screens, sometimes you need to tell the app, certainly like if you go to the user menu and choose log out, we want to tell the app to go back to the login screen. And so sometimes you're telling the user navigator to do something, which is switching to different screens within that. But sometimes if you want to do an app-wide navigation, like I'm done with user content, let's go back to the login screen, you can also have reference to the app navigator.
I see.
Change that. Yeah. So the app navigator controls what view controller is. It's the root view controller of the UI window that the app lives in.
Right.
But then once you're inside of that, say when you go to the user content, that may be a UI navigation controller that lives inside that window. But for that navigation controller, since it is its own view container, then you have a separate router navigator to control, say the user content section of the app.
Okay, so this is an interesting thing that you just described. Okay, I want to talk about that a little bit. So basically, let me try to rephrase it and correct me if I misunderstood. In some circumstances, and specifically like that login logout case, you actually might be having a second router from somewhere up the chain of Viper stacks, right? Perhaps this application router. And your, let me find this thing, arrow. And then your presenter has a reference to essentially both, right? Its own router to route to something within its context, and then to this other, let's say, application-wide router, right?
Right. And that also sort of goes back the other way. So as we added deep linking in the app, it's useful to, depending on which way you're going, it's useful to have access to these multiple routers throughout the app. So if the user opens a deep link, if you needed to go somewhere else, you just need to make sure you have access to the appropriate router that can get you where you need to go.
I see. So that's also okay. I think, Sandeep, that's exactly what we had for another use case of site switch, right? Where, it wasn't the Viper portion of the app, but we kind of adhered to some of the principles of like encapsulating things. We had a collection of view controller and view model. And in our case, view models are actually business objects. They're just called view models. But anyway, we had this similar case of somewhere deep in the hierarchy of view controllers and view models, something was triggering a logout or a site switch, which is a logout and login at the same time in a sequence. What we ended up doing, and it was inspired by ribs actually. So what you're describing, Jeff, is kind of not cross. I don't even know how to call it. You're taking
Maybe parent router.
yeah, you're sort of sort of like a parent router, and it's allowed and passed down to one of the children, right?
Right.
What ribs architecture advocates is the total encapsulation, right? Children cannot kind of share those objects from the top, or at least the router specifically. What they can only do, let's say this down the chain here triggered a user, user indicated here that the user wants to log out, but logging out can actually only happen here because this is app router is here. What you do instead is through delegates, you pass up the chain the message about it. And then you pass to this guy, and this guy's like, oh, I cannot do login out. Let me pass it to my parent. And then eventually, you get to this root of everything, which is app router, and that's where you can actually handle it.
Okay.
And then you do it there.
Well, cool. Oh, yeah, and as you say, each app certainly has its own set of problems it's trying to solve requirements and the way it goes about it. Yeah. So, there's certainly never one way to approach everything. Yeah. I mean, and so as long as you just sort of remember sort of what your sort of core principles are that your architecture is sort of optimized for and what it's trying to help you achieve, then the challenge is how can I sort of take my core values and principles and create a solution to whatever the unique problem is I'm faced with today.
Right. Yeah. And I'm certainly not trying to say like, oh, one was better than the other. They're just they're different trade-offs, right? Because as always, right, freaking software, it's always trade-offs. Like in this, what I just described, this chaining, bubbling up from the bottom of the tree structure of your app up to the parent, and deferring decision making on how and where to actually log out, for example, has its disadvantage of that boilerplate. You have to write so many freaking delegates and wire them up, and it's so annoying. The other way around, what you were describing, essentially it would be kind of like this. The container VIPER stack has the app router, and it will pass it down and inject it into this guy, right? This price VIPER. And then eventually app router will be passed down and injected in that one down the chain, because this is where it actually will be called to log out, right?
Right. Yeah. And that doesn't bother me personally, just because, and I don't see that as a problem necessarily, just because I think it's okay to have access and visibility of things with a longer lifespan than you, but you certainly don't want to be holding on to things with a shorter lifespan than you, because that's where you can get into trouble.
Right. That's one trick there. But I think if you explicitly are passing two routers, one is of that stack and another one of outside, and you have two different interfaces for both clearly, right?
Yeah.
Then it's probably fine. You are still in the same situation though of boilerplate code of injecting it somehow, right? Or having some factories or some other clever way of passing it down.
Yeah, you have to inject the parent every time you go down the hierarchy.
Right.
Exactly. Yeah.
Right.
Yeah. So certainly some of my Leaf factories, they may have 10 or 15 dependencies injected into that factory, because those are objects and dependencies with a longer scope or lifetime than that sort of Leaf factory. And you say it's not the prettiest thing, but I haven't. It doesn't bother me enough to try and find another solution, but I'm always open to things. And certainly, as you were saying, like with the rib stuff, probably one of the things they were optimizing for is the team size.
Yep.
Uber is known to have really large teams, and by just making everything fully self-contained and just exposing
Mm-hmm.
things up through delegates allows that to have little teams, separate teams, focus on each little part without stepping on each other. And so
Yeah.
that certainly does have its own cost, but if you're dealing with a large team, you need to solve large team problems, which wouldn't be necessarily useful or valuable. If you applied this to a small team, and vice versa, the way a small team approaches things isn't going to work well. One person team is going to work differently than a 50-person team.
That's a good point, and that's actually what Sandeep and I kind of intentionally decided, because we talked about all of those things a lot too. Like, we're a team of two actually, so for us, even though I personally, probably if I was a team of one, I, I don't know actually, would I go with Viper or not for myself? But what we decided to go with is some sort of a semi, it's not Viper, but it's, as I was mentioning, the view controller view model combination, where at least all the business logic and all of everything that's not view and UI related, almost everything, is taken out of the view controllers into the view model, and that is the thing that does the business logic, and we can unit test. Sort of, that helps us right now, right? We do have some issues occasionally with assembling those and having or not having factories where we want them for those groups of view controllers and view models. But for our size, right, we don't need to optimize yet for multiple teams working on portions of the app, and we're not splitting anything into frameworks yet, or at least frameworks per feature.
Yeah.
So yeah, different problems solved, right? And its scale on mobile is really all about your team size, not the user size.
Exactly. Yeah, and that's So going back to every team has their own unique set of problems to solve, and so as long as you just sort of have those core principles that drive your decisions, that's what you can always fall back on to help you solve whatever problems come along to your team that no other team has seen yet.
Yeah.
And you mentioned that or you had experience working in a code base where some portions were Viper and the rest of the system wasn't. And if you're working in such a code base and you sort of wanted to drive more of it towards Viper, I think a good place to start is just getting your navigation system in place, because you may have view controllers, that you using singletons and shared instances all over the place, and very little is getting injected. So if you can at least start to introduce the notion of a router in a factory paired together,
Right.
you could leave all your view controllers initially just grabbing all their singletons everywhere. But then once you have their creation all pulled into your factories, then you can start to introduce a dependency injection, and then that will allow you to start to separate responsibilities, like pull out the use case or pull out the interaction design from your view controller. So so I think really having a good navigation system in place is the core benefit that allows a bunch of other architectural enhancements down the line.
Yeah, I think I totally agree. Where we started, as of right now, our routing navigation is kind of deferred to view controllers by default, because it definitely doesn't belong in the view models that we created, because they're all about the business logic, right? And if we do import UI kit there, we failed to separate the concerns, right? But I think for us, at least from my perspective, the main pain to start putting everything in order, if you will, at least somewhat, is the dependency injection part.
Yeah.
Routing is actually, we could kind of live with it for now ish, but the whole dependency injection, where our all of this service objects for networking, for core storage, whatever,
Right.
Like we have so many instances of them because they're getting created in convenience initializers. And I was telling Sandeep yesterday that I'm starting to think that if you use a convenience initializer in Swift, it's a code smell and you need a factory there.
Interesting. I'll go look and see if I have any.
But like, what do you use it for, right? To conveniently initialize something. Oh, why do you need to conveniently initialize something? Because you have like a bunch of services or whatever that
Yeah.
you're injecting, and you're actually not properly getting them from like root of your application, but like initializing them in a place.
Yeah. Exactly. Yeah. So you sort of want to so if your view controllers are creating their own destination view controllers and pushing them on a stack, yeah, that's sort of what you want to pull out. And so then, yeah, so certainly you want a place for those factories to live such that they have a longer lifespan than the view controllers themselves that are using them.
Yeah. Nice. Okay, this was a great conversation. I think we covered a lot and like specific nitty-gritty details of how to arrange and organize, Viper code bases. It says
Excellent.
this was very insightful. Anything else, Sandeep, you wanted to ask, or Jeff, you wanted to share?
Yeah, just a small question. So since we have discussed the interaction from child to parent, so I was wondering, how about siblings? What if siblings want to interact with
Good
each other?
question. Yeah.
So will they step on each other like router? Will they share common router or will they share common presenter? How will that go?
So like if you do something in the product details section and you want it to maybe do something on the reviews, like maybe have it navigate to a different page or something.
Or perhaps even just data change, right? Maybe some selection here in product details somehow.
Yeah. For example, a good
changes.
example could be like on Amazon, we have, if we go to choose a shoe for us, there they show a different size, and according to different they have different prices available, right? So changing the one thing in detail can change something in price section. So
Okay.
how we can accomplish this with Viper then?
Yeah, so at that point, I mean, so this then becomes a little more complicated system, and that is certainly, on a side note, developers always love to remove complexity and make things appear simple. But certainly, if you are in a more complex situation, to me, it is acceptable and probably desirable for the code to look more complex to reflect that underlying complexity. So, for example, let's say if product details, price, and reviews truly were independent of each other, then that is pretty simple. But now you actually, if you want to introduce dependencies between them, that does complicate the system a little more. So it's okay to have a more complex solution and, a more complex code in that case. So, you may need just a separate communication mechanism tying together, say, product details and price, such that change in one can reflect a change in the other. So,
do you think
so?
Yeah, go ahead.
So you can imagine, like, if you're like in the price, sort of the use case of pricing is, if I have product A, I want to see all the pricing information around it. And so then, if you all of a sudden you want to look at product B instead, you would ask the use case, give me all the pricing info for product B, and then I can present that to the user. And so in that case, maybe product details, when you change it, if you know that the price wants to change, one possible solution is maybe your product details presenter, the interaction design, it may have reference to two separate use cases. It may have one to the product details use case, the product details interactor, and it may also have a reference to the price interactor. And so when you change, you just tell the price interactor, go get me the price for product B now, and then it'll fetch it. But the little price Viper stack is listening to that same use case. And so when it has new content present, it can say, oh, here's your new price information, please update.
Mm-hmm. I see.
That could be one approach, or it depends on the nature of the collaboration. Maybe everything does need to be sort of routed up through the container.
Right.
I mean, if changing something in the reviews changes the product details, I mean, that may seem contrived, but if changes in any view can affect any of the others, you may want to bubble all that up to the container to let it make that coordination between, if something changes here, I need to make, maybe request new data over here.
Mm-hmm. Yeah, that would have been my go-to. Any updates, let's say there was networking or user selection, right down here, you via delegate one-to-one connection, you pass it up here because you can't do anything about it on this level, right?
Right.
If you really want to have a clear wall between these two guys, right? Because they're siblings, they should know about each other. They're not initializing and routing to each other. Then the only choice you have is to bubble it up some way, right? There are different ways of doing it via delegate or maybe observable notification, whatever, right? And then this guy pushes it down to this one or both, right? Processes and pushes it down.
Right. Yeah. So ultimately, the price stack needs to know that I need to ask for pricing on a new product.
Mm-hmm.
And so the business question is, who is in the best position to know when you're looking at a different product and how to tell them?
That's a good way to put it. Maybe perhaps they share a storage object, right? That's the same one that's injected when from here you route to both. You just inject the same storage object and they sit there and observe it or something.
Oh, yeah. That would work too.
Yeah. But yeah, this is where it becomes complicated, right?
Yeah. I mean, yeah, certainly that is a more complex system than just an entire screen controlled by a single VIPER stack.
Yeah, so, I think perhaps this would be an easier case for that, right? You would have just one interactor and then a bunch of presenters. So yeah, it could go through that little center point.
Exactly. Yeah.
Very interesting.
Thanks, Jeff. That is definitely a very nice answer. And yeah.
Oh, you're welcome.
Cool. All right, guys. Anything else you want to talk about we haven't covered? Or that's pretty much it?
I think, we covered quite a bit today. I'm sure we can continue to talk about more and more stuff on a future day.
Yeah, or maybe we can code next time. Who knows? We got the diagrams, the next steps to code, right?
That's right.
Or sometimes on some teams I've seen it's the other way around. You code, you code yourself into a corner, then you start diagramming to figure the thing out. Okay.
And I want to actually thanks Alex to you actually. So because of you, I got to know about Jeff. Like VIPER architecture, I learned about it a few years ago, but never thought I would be meeting the author of VIPER one day. So that's great to have direct conversation with you, Jeff.
Excellent. Well, I'm always happy to talk with anybody about this. It's fun stuff. And saying if anybody wants to chat with me more, I am on Twitter at HeyJeffG, and I'm also on the iOS developers Slack group.
Nice. What about you, Sandeep? How can people reach you?
Yeah, so I'm also on the same iOS developers Slack group, and people can reach out to me on my Twitter handle. It's SandeepCool77, or they can shoot me an email at agarwal.sandeep77@gmail.com.
Nice. And yeah, guys, you can reach me at hello@InsideIOSDev via email and InsideIOSDev.com, and then on Twitter at InsideIOSDev, and leave comments actually in this new YouTube channel of mine. It's probably going to be easier to interact via that, because you can see this diagrams, what we screen shared, and comment on specific even minute of it, right? And please like and subscribe, as all YouTubers say, but it really helps to boost your channel in the YouTube algorithms and such. Other than that, yeah, thanks everyone. Thank you guys for your time, and I'll see everyone next time.
Thanks again. I appreciate it. It was a lot of fun. Talk to you later.
Bye.
Bye.